During today's video, I'm going to be showing you how to solder the CyberPet microcontroller circuit, which is found on the Picaxe website. And later, we're going to be using this same circuit to program this microcontroller right here on the Picaxe software. This circuit uses the Picaxe 08M2 microcontroller. And this main component is going to act like the brains of the circuit, which controls the other components. And as you could see, this microcontroller is packaged in a dual inline package. So you're going to need the appropriate socket for it. So, what are you going to need in order to solder your circuit? So first of all, you're going to need the PCB. You do not necessarily have to solder your circuit on this PCB, which is, by the way, found on the Picaxe website. However, this is much more convenient as you have everything labeled. Like for example, here you have the labeling for where the LEDs are going to be. And here you have where the negative lead should be, thanks to the flat side of the circular symbol. The LDR, the buzzer. You also have the resistors with their values labeled onto this PCB. Now, if we had to turn it around, here we're seeing the solder pads. Basically, these are the pads where you're going to be soldering the leads of your components. And since this is a PCB, here you're seeing the tracks. You're seeing to which component each lead is connected to. Hence, that is why having a PCB is much more convenient than soldering on a strip board, for example. Now, along with the microcontroller, you're going to need a number of resistors. One 22 kilo ohm resistor, two 330 ohm resistors, and three 10 kilo ohm resistors. Now, as stated before, since my microcontroller is packaged in a DIL packaging, that is dual inline packaging, you're going to need this socket right here that goes along with it. This socket right here is the item that's going to be soldered to our board, and then later the microcontroller will be inserted to this socket later, because as we all know, you cannot solder ICs directly to your board, otherwise you will damage them with the heat. As a sound output component, we're going to be using this piezo buzzer. Then to download our program to the microcontroller, we're going to be using this stereo jack socket. Here are the pins, and just like any other component, those pins will help us solder that component in place. Then we have a tactile switch to be able to either start up or turn off a program. Here we have the battery pack and the battery clip as well, which goes with it. Here we have the LDR, just in case we need a sensor to sense darkness or light. And here we have another two output components, the LEDs. So we have two red LEDs. Okay, that's everything. Now let's start soldering. Let's put the board into this helping hands. Now, of course, I'm going to start with the trickiest component to solder, and that is going to be this IC socket. So first, let's place it onto the board, make sure that it is flat and that you're seeing the leads from the other side, from the soldering side of the board. Now, you have to be careful on how you place the IC socket. You have to always make sure that this notch right here is pointing upwards, according to how the labeling on the PCB is. So this notch right here should be on this side of the board. Okay, and here on the PCB you also have labeled where pin 1 of your IC should be. So let's push the IC socket there. Now of course you cannot expect to hold both the IC socket and the PCB together with the helping hands. So to help you keep the IC socket in place, I'm going to use a piece of masking tape. I'm going to place this tape over the IC socket and then taping it to the PCB. So this tape will help me hold the IC socket while I solder it in place. Alright, now let's hold the board on the helping hands. Make sure that you're faced with the soldering side of your board. Here you have the leads. So what we're going to do is to solder each lead of the IC socket one by one. Now before soldering, make sure that you have your solder and a damp sponge prepared. So here I'm going to bring the soldering iron. First I wait for it to heat up. Then I'm going to tin the tip of the soldering iron. Place the tip of the soldering iron onto the lead and the soldering pad, and then introduce some solder, and then move the soldering iron upwards. And I'm going to repeat these steps for all of the pins. So first place the soldering iron touching the lead and the solder pad, and then introduce the solder. And remember, to create a neat solder joint, you need to move the soldering iron upwards, touching the lead while touching the lead of the component. And it's always ideal to tin the tip of the soldering iron before, so it would be easier for the solder to flow and adhere to your component lead. Then when finished, put the solder aside and clean the tip of your soldering iron on a damp sponge. And then, to prevent any hazards or fires, remember to place your soldering iron back into its soldering iron stand. Now remove the piece of masking tape we have put on the component earlier on. And there you go, that's our first soldered component. Now let's move on to soldering the resistors. Now here in my hand I'm going to solder the 10 kilo ohm resistors, and as you could see on the PCB you have these 3 resistors labeled. So let's remove the paper which holds them together. And now to solder a resistor, you're going to first bend the leads as I'm going to show you here, like this. And then you're going to insert the leads through the available holes. So make sure to keep your resistor flat against the PCB. And to keep it in place, to avoid having it drop, you're going to turn your board over and then bend the leads as I'm showing you here. This way the component will not fall. Let's do the same for the others. So bend the leads and then place them in place. Place them where indicated on the PCB, and then turn the board around and bend the leads as shown, so your resistors will not fall off while you solder. Now that is all of the resistors placed. Now for the last one, I'm going to leave one of the leads standing up. However, make sure to bend it ever so slightly so the resistor will not fall. So place the board onto the helping hand as shown. And now let's attempt to solder that standing lead of the first resistor. Now let's bring our soldering iron. Now before you solder, make sure that you tin the tip of your soldering iron. Then touch the lead, the component lead, and the solder pad with your soldering iron. And then introduce solder. Move upwards and then clean the tip of your soldering iron on the damp sponge. Do the same on the other one. So let's straighten the other lead. Tin the tip of our soldering iron. Place the soldering iron touching the component lead and solder pad, and then introduce solder. Always make sure to move upwards when you're soldering, when you're finished soldering. So you're always going to have that volcano-shaped solder joint. And then clean the tip of your soldering iron. Let's do the others. Now when you're finished soldering your components, make sure that every component is soldered well and that no component has fallen off. And now let's trim off the access leads with a side cutter. Alright, now let's solder the 330 ohm resistors in place. And once again, the same steps are going to be followed in order to solder these components. So bend the leads of your resistors. Place them in place according to the labeling on the PCB. Turn the board around. Bend the leads of the resistor. And then you could solder them. Just make sure that you would straighten one of the resistor leads. Because of course you cannot solder a resistor lead while it is bent. Now clip your PCB to the helping hands with its crocodile clip. Here with the crocodile clip of the helping hands, I'm also holding the leads of the resistors. And now let's start to solder. Do the same steps as before. First tin the tip of your soldering iron. Place the soldering iron touching the component lead and the solder pad. Then introduce some solder touching the soldering iron and component lead. Then move your soldering iron upwards. Then clean the tip of your soldering iron. Do the same steps for the other leads. Then when finished, cut the excess with side cutters. Now let's solder the other leads. Alright, last resistor left. This is the 22 kilo ohm resistor, and that we have to place it here where there's the 22K labeling along with the resistor symbol. Remove the paper which is attached to the sides of the resistor, bend the leads, place it where indicated, also, the resistor doesn't have a polarity, so it doesn't matter to which direction you place it. Just make sure that the component is on the component side and the leads are on the soldering side. And let's repeat the soldering steps. So clean the tip of your soldering iron, tin the tip with some solder, and then heat up the lead and solder pad, introduce solder, move the soldering iron upwards, and then clean the tip once again. And then cut the excess with the side cutter. Now here I have incidentally put a little bit too much, so I'm going to solder the other lead and then remove the excess solder later. Okay, now the solder joint should have cooled down by now. Now to remove the excess solder, you first have to heat up the solder joint. And then we're going to use a tool called the desoldering pump. Make sure to press the plunger down of your desoldering pump. Place it near the soldering joint, and when heated up to a fluid state, press the button on your desoldering pump to remove the excess solder, and then press down the plunger again to remove the solder inside the desoldering pump. Now if there's enough solder, you could simply heat up the solder joint and move the soldering iron upwards. However, if there's not enough solder, then you might probably want to resolder the solder joint once again. Then cut the excess lead with the side cutter. Now let's solder in place the stereo jack socket. So first of all, you're going to push the stereo jack socket through the holes of the pins. Make sure it clips in place and that you are seeing the leads on the other side. So let's clip the board on the helping hands. And to solder, we have to follow the same steps. First, tin the tip of the soldering iron while the soldering iron touches the lead and solder pad. Don't worry if this time the two solder joints touch each other. As you could see, if you look closer to the solder pads, which are next to each other, are joined. So this time it doesn't matter if the two solder joints were to touch each other. Now let's solder the last pin and then we'll move on to the next component. Now we're going to place the two LEDs. So here's the LED, and as you all know, the LED has an anode and a cathode. The longer lead is the anode, therefore it is the positive side, and the shorter lead is the cathode, which is the negative side. Now the cathodes of the LEDs have to be placed right next to the flat side of this circular symbol. So push your component through, and now to keep the LED in place, you have to bend one of the LED's leads. And to keep it securely in place, I'm going to be clipping it along with the circuit board in the crocodile clip of the helping hand. Now let's solder the cathode of this LED. Same as we always do. First tin the tip of your soldering iron, then touch the lead and solder pad, and then introduce just a little bit of solder. Now let's solder the positive lead. Make sure that you straighten the lead before you solder it. Tin the tip of your soldering iron. Touch the solder pad and the lead, and then introduce some more solder. And then trim the excess with the side cutters. Alright, now let's place the other LED in place. Make sure that the cathode of the LED is right next to the flat side of the circular image printed on the PCB. Now, once again, to keep this LED securely in place, make sure to bend one of the leads downwards. Now place the PCB and LED lead into the helping hands. Make sure that they are gripped with the crocodile clip. And now let's solder the straight lead. Make sure to not put too much solder because we don't want the solder joints to touch each other. It's important that both connections are kept separate. So straighten the other lead and solder it. When finished soldering, make sure to clean the tip of your soldering iron and then place it back into the soldering iron stand. Now let's trim the excess leads with the side cutter. And then we'll move on to the next component. The next component that we're going to solder is going to be the LDR. Now, when placing the LDR, it doesn't matter in which position you place it, because the LDR does not have a polarity. So let's just place it like this. Now let's bend the leads to prevent the component from falling off. And let's clip it onto our helping hands. Straighten one of the leads. And let's solder it. Now let's solder the other lead. And then trim the excess leads with the side cutter. Now we're going to solder the buzzer in place. Now this buzzer right here does not contain a polarity, so it doesn't matter in which side you put it. Now let's push the component leads through the drilled holes of the PCB. Make sure that you're seeing the leads on the other side. Now to keep my component in place, I'm going to use a piece of masking tape to tape it over the component to keep it in place while soldering. Now let's place our PCB onto the helping hands and let's solder the buzzer's component leads. Now let's solder the last lead. And the next component that we're going to solder is this tactile switch right here. And you place the tactile switch like this. So press the tactile switch in place. Please be careful on the direction on how you're going to place the tactile switch. Please do not place it the other way around. Alright, so that's the tactile switch in place. Now, fortunately, with the tactile switch's leads are already bent, so it will stay in place while soldering. So let's tin the tip of the soldering iron and let's solder all of the leads. Make sure to always move upwards when soldering. Otherwise, you will not have that volcano-shaped solder joint. Now it's time to solder the battery clip in place. Now as you could see, the battery clip has a red and black wire. The red wire represents the positive side of the battery. The black one represents the negative terminal of our battery. Now, these wires have to be soldered right here. Where you have V plus is where the red wire is going to be. And where you have 0 volts, that is where the black wire is going to be soldered. Now, of course, I'm not going to solder them directly to those 2 holes because otherwise, if this wire were to be yanked by someone, the wires will be easily disconnected and we don't want that. So, to avoid that from happening, I'm going to first put the 2 wires right through this first hole right here. Then, from underneath the board, I'm going to curve them and put the 2 wires right through the second hole. Then I'm going to bend the wires again and I'm going to place the red wire where there's the hole labeled V+. Then I'm going to place the second wire, which is the black one, through the hole labeled 0 volts. Now let's pull a little bit of the access wire. Make sure that your wire looks something like this. And now let's solder those 2 wires. I pulled the wire a little bit so the wire would stay in place. Now, of course, you know the steps for soldering. Now let's repeat them for these 2 wires right here. Now let's move the access wire, which is up here. Now let's push it downwards. From this side, let's keep it like this, and then push it upwards. Now, of course, I'm moving the access wire a bit outwards, just so the wire could be more rigid, also to be more neat. Now, for this microcontroller circuit to work, with this extra wire right here, I'm going to connect holes labeled CF and PX together. So let's insert the wire like this. Insert the first copper bit to the hole which is lower the label CF, and the other wire to the hole which is under PX. Like we did with the other components, let's bend the leads to keep the wire from falling, and let's solder it. Always, while soldering, always follow the prior steps that we have followed before. So tin the tip of the soldering iron, heat up the lead and the solder pad together, then insert the wire of solder, let the solder flow, and then move your soldering iron upwards to create your solder joint. Make sure to never put too much solder. Now straighten the other lead and let's solder it. And now let's cut the excess copper wire with this height cutter. And there you go, that is our finished soldered circuit. All is left for us to do is to insert the microcontroller IC itself. Now this is the microcontroller IC, and as you can see, it has a number of pins. Each pin has a different number. Pin number 1 is located right next to this notch right here. Do you see this notch? Right next to it is pin number 1. Now this IC's leads are bent slightly outwards. So in order for it to be a bit more easier for me to insert the IC, I'm going to bend them slightly inwards by pressing them on a flat surface. Here they're still slightly bent outwards, so let's bend them a bit more inwards. Make sure that the leads are bent 90 degrees. And remember that when placing the IC in place, make sure that pin number 1 is right next to the label number 1 on the PCB. So let's insert the IC into its socket. Press it gently. Always be careful when inserting ICs into their socket, because otherwise you may risk in bending the IC's leads. Now let's attach the battery pack for the 3 AA batteries that are going to be the power source for this microcontroller circuit. So here we have the battery pack, and let's attach it to the battery clip like this. And there you go, this is our finished assembled microcontroller circuit. Now see you on the next video, where I'm going to start to be programming this microcontroller.